The front end is operational. We now proceed to the backend build. This encompasses the database, the API, authentication, and all the data connections that make the application functional. However, we will not be writing this code manually. Instead, we are going to orchestrate its creation using a team of AI agents.
This technical walkthrough is divided into 6 sections. We will cover the blueprint for orchestration, the necessary tools and accounts, the philosophy behind using AI skills, the specific AI specialists will configure, how to connect our database, and finally, the expected deliverable. We begin with the core workflow. The fundamental concept here is that we are not writing code. We are directing specialists who will write the code for us, and this requires a very precise, repeatable process. This process consists of 5 main steps. First, we install 2 AI agents into Visual Studio Code. Second, we set up 4 required free accounts for our cloud services. Third, we will write 10 specialist skills that define the rules for our AI. Fourth, we connect our database directly to the primary AI agent. And fifth, we will send a single master prompt to initiate the entire backend build. So let's start with assembly. This first phase involves installing 2 specific VSCode extensions and then creating accounts for the 4 cloud services that will power this project.
The 2 AI agents are Codex and Kilo Code. Codex is an OpenAI agent that reads the entire project context and makes direct changes to your files. It's extremely efficient for generating code and applying standard patterns. Kilo Code is a second agent we'll use. Its strength is in multi-step reasoning and architectural planning before it writes any code. We will leverage both of these capabilities.
4 free accounts are necessary to proceed. First, you'll need a GitHub account for version control, which is essential for our deployment pipeline to Vercel. Second, an OpenAI account is required to authenticate the Codex extension. Third, a Kilo Code account is needed to authenticate the Kilo Code extension. And fourth, a Supabase account. Supabase is our backend-as-a-service platform providing a PostgreSQL database, user authentication, and an auto-generated API.
Before defining the skills themselves, it's critical to understand the philosophy behind them. This is the most important concept in this entire module. It represents a fundamental shift from repeating instructions to orchestrating specialists.
So, what is a Codex skill? It's a saved, reusable set of instructions. You define a specific set of rules for a domain, like backend engineering or security, one time. From that point on, Codex applies these rules automatically and consistently whenever it works on that part of the project. You don't have to repeat yourself.
The required mindset shift is this. The skills are your team of specialists. You are the director. Your job is to brief them once on the project's rules, and they will execute on those rules every time. These skills are also global, which means the specialist team you assemble for this project can be reused on any future React application you build.
All right, let's meet the team. We will now define 10 distinct skills. Each one covers a specific domain of expertise, and together they form the complete set of rules that will govern our entire build.
We will use a total of 10 specialists to form our expert AI team. Let's break down each one.
Skill 1, the front-end architect. This specialist enforces our stack, React 19, Vite, and Tailwind, along with functional components and a mobile-first design standard. Skill 2, the back-end engineer. This skill enforces a Node.js and Express REST API, the use of async await, and the proper security practice of storing JWTs in HTTP-only cookies. Skill 3, the database specialist. This enforces the use of Supabase and Postgres, requires version SQL migrations, and mandates role-level security on all tables. Skill 4, the QA specialist. This acts as an automated tester, identifying hard-coded values, ensuring all component states are handled, and testing edge cases. Skill 5, the web security specialist. This enforces OWASP standards to prevent attacks like SQL injection and requires that all permission checks are performed on the server.
Moving on, Skill 6 is the SEO specialist. It ensures every page has unique meta tags, open graph tags for social media, and includes a sitemap.xml. Skill 7, the deployment specialist. This skill manages our deployment pipeline, environment variables, and configures production-ready CORS policies. Skill 8, the code reviewer.
It maintains code quality by flagging duplicated logic, enforcing naming conventions, and removing stray console.log statements. Skill 9, the performance engineer. This specialist is responsible for speed, enforcing a lighthouse score above 90 through techniques like code splitting and lazy loading. And finally, Skill 10, the API architect. It enforces proper REST design principles, correct HTTP methods and status codes, and will even generate a Postman collection for API testing. Now that our specialists are defined, the next critical phase is to establish a direct connection between our AI agent and the live Supabase database. This allows the AI to work with the actual database schema, not an approximation of it.
This is a 5-step process. First, get the API keys from your Supabase dashboard. Second, create a .env file in the project root to store these secrets. Third, add .env to your .getignore file to ensure secrets are never committed to version control. Fourth, enable the Supabase Model Context Protocol, or MCP, within the Codex extension settings. And fifth, verify that the connection is active. The .env file will contain 7 environment variables. Supabase URL is your project's unique URL. Supabase anon key is the public safe key intended for front-end use. Supabase service role key is the private admin key for the backend and must be kept secret. JWT secret is a random string used for signing authentication tokens. Resend API key is the key for our transactional email service. Vit API URL is the local API endpoint for the front end during development. And finally, node env will be set to development.
At this point, we issue the master prompt. This is a single, comprehensive command that instructs Codex to execute the build in 4 distinct phases. Phase 1 is to build the database schema and populate it with seed data. Phase 2 is to scaffold the entire backend Express API. Phase 3 is to integrate that new API with our React frontend, replacing all the mock data. And Phase 4 is to run audits for quality, SEO, and performance, based on the rules defined in our specialist skills.
Once the AI completes its work, the final state of the project will be a production-grade application, fully wired and ready for the next stage of development. Let's review the specific deliverable.
The outcome is a complete application. You will have a live Supabase database with tables, data, and active security policies. You will have a secure Node.js Express API with all required endpoints. The React frontend will be fully integrated with real data from that API. And, perhaps most importantly, your 10 specialist skills are now saved in Codex, ready to be reused. The project is now ready for testing and deployment.
The backend has been built. The data layer and the API have been fully orchestrated by our AI agents according to our rules. The immediate question is, does it work? In the next module, we will answer that by installing the project's dependencies, starting the local server, and conducting the first round of end-to-end testing.